Hi, in this video I am going to talk about the flow of control statements. So how we are going to translate the boolean expression into three address code in the context of statements generated using the following grammar. So what are the grammars we are going to consider here is, there are three grammars. First one is S points to if of B S1. This is a simple if statement. So here what is B denotes for is, B denotes for boolean expression. So we evaluate the boolean expression. If B is true means then the statement S1 will be executed. And second one is a if else statement. So yes, here S denotes for a statement and B denotes for boolean expression. S points to if of B, that is a boolean expression. If the boolean expression is true means statement S1 will be executed, or else if the condition is false means statement S2 will be executed. Then statement S while of B of S1. So here again the B will be evaluated. If the condition is true means then the statement will be executed. As we all know, the loop S1, the statement inside the loop, that is S1 will be executed until the condition B becomes false. So here in the boolean expression, as we all know that there are two attributes we have. One is the synthesized attributes and other one is the inherited attributes. The synthesized attributes associated with the boolean expression and statements are b.code and s.code. It gives a translation into three address instruction. So b.code represents the synthesized attributes for boolean expression, and s.code represents the synthesized attributes with statement. So what are the inherited attributes that are associated with the boolean expression and statement is, one is b.true and other one is b.false. So b.true means it is a label to which the control flows if B is true, and b.false denotes for label to which the control flows if the B is false. And we have a s.next. It is a label attached to the first three address statement to be executed immediately after the code for S1. And there are two functions we use. What are the functions we used in the syntax directed definition is, one is a new label. What is the function of the new label is, it will create a new label each time it is called. And the other one is a label of L. Label of L attaches label L to the next three address instruction to be generated. And here next one we are going to see about the different syntax directed definition. So first one, for the production P points to S. These are the semantic rules. Here what is S dot next is, S dot next equal to new label, and P dot code equal to, first we are evaluating the S dot code, and then it will follow to the label of S dot next. The next production is S points to assign. So S dot code equal to assign dot code. So here P points to S. The program P consists of statement capital S. Here we have a S dot next, that is initialized to new label. P dot code consists of S dot code followed by the new label S dot next. Assign means it is a placeholder for the assignment statements. Next one is S1 or S2. Here S1, first one S1 dot next. What is S1 dot next is, S1 dot next equal to new label. It will create a new label. And what is S2 dot next? The S2 dot next denotes for this. What is S2 dot next is, it will be the S dot next. So S2 dot next equal to S dot next. Now we are writing the code, that is syntax directed translation. First we are evaluating S dot code, that is S dot code equal. First we evaluate S1 dot code. If it is true means then it will go to the label of S1 dot next. Else it will evaluate the S2 dot code. So the first instruction after the code S1 is the beginning of the code for S2. This is the syntax directed definition for the boolean expression. S points to if of B comma S, f of B S1. So this is a simple if statement. So in this simple if statement, we evaluate the condition. If the condition is true, that is Boolean expression is true, means statement S1 will be executed. So this is a diagram. In this diagram, first what we do is we are evaluating the B dot code. So we are evaluating the B dot code. So this is actually the B dot code. So B dot code is evaluated. So there are two conditions when we evaluate. Either Boolean condition may be true or the Boolean condition may be false. So B dot code, either it may points to B dot true if the condition is true. B dot code may points to B dot false if the condition is false. So if the condition is true, means S1 dot code will be executed. False means whatever statement after S1 that will be executed. So there are two labels. One is B dot true and other one is a B dot false. Okay. So as I told, we are evaluating the B dot true. We are evaluating B1. Suppose B is true, means it will create a new label. It will create a new label. If the B is false, suppose B is false, means whatever the statement after the S1 that will be executed. So that is S1 dot next, which is equal to S dot next. Now we are writing the syntax directed definition for S dot code. So S dot code equal, first we evaluate the B dot code. If the condition is true, means it will go to the label of B dot true. Then S1 dot code will be executed. S1 dot code will be executed. So we create a new label B dot true and attach it to the first 3 address instruction generated for the statement S1. So it will create a new label B dot true and attach it to the first 3 address instruction generated for the statement S1. Within B dot code are jumps based on the value of B. If B is true, control flows to the first instruction of S1 dot code, and if the B is false, control flows to the instruction immediately following S1 dot code. Next one, we will see the if-else statement. We'll see the if-else statement. So in if-else statement, there are two conditions. Either B may be true or B may be false. Here, when we evaluate the Boolean expression, so the Boolean expression may be true or it may be false. So this is a diagram for if-else. We evaluate the B dot code. So when we evaluate the B dot code, so the condition may be true or it may be false. If it is true, S1 dot code will be executed. Okay, if it is false, then S2 dot code will be executed. So this is a syntax directed translation. First, we have to create two labels, one for true and the other for false. So if B dot true, we create a new label, that is B dot true equal to new label, B dot false equal to again new label. So what is S1 dot next? So S1 dot next equal to S2 dot next equal to S dot next. So now we will write the syntax directed code. First we evaluate the B dot code, sorry, S dot code. S dot code equal B dot code. We evaluate the B dot code. There are two conditions, two possibilities. Either it may be true or it may be false. If it is true, means it will go to the label B dot true. If it is false, it will go to the label B dot false. So first one, label of B dot true. If the B dot code is true, then S1 dot code will be executed. So in B dot true, what is the statement we have is, we have a statement s1.code. So s1.code will be executed. So after executing the s1.code, it will go to s.next. So that's why gen of go to s.next. If b.code is false, means it will go to the label of b.false. So in b.false, we have a statement s2.code. So that will be executed. So as I told, we have created two labels, b.true and b.false. Suppose b is true, means it jumps to the first instruction of the code for s1. If the b is false, jumps to the first instruction of the code for s2. The control flows from both s1 and s2 to the next to the 3 address instruction immediately following the code for s. So here, what is the use of go to? An explicit go to s.next appears after the code for s1 to skip over the code for s2. So what is the use of this go to statement is, suppose the condition is true, means there is no need to evaluate the s2.code. That's why we have given the go to of s.next. So no go to is needed after s2 because s2.next is same as s.next. Next one is while boolean expression, that is s points to while of b comma s1. As we all know that in while loop, it will evaluate the condition. The condition is true, means the statement 1 will be executed. If it is false, then only it will go to the s1.next. So again, we have b.code. So in b.code, we have two possibilities. Yeah, the condition may be true or condition may be false. b.true and b.false. If the condition is true, means s1.code will be executed. Okay. So after executing the s1, again it will go to the while. So that's why we have created a label begin. For begin, we have created one label. So immediately after executing s1, again it will go and check the b.code. If again condition is true, means again it will execute the s1.code. Okay, now we will come to the semantic rules. We need to create two labels, one for begin. So begin, we have created a new label, and b.true, we have created one label, new label, because we have two labels, one for begin and other for b.true. Okay, so b.false. What is b.false is, it will be s1.next. Whatever be the s1. Whatever the next of s, that will be the b.false. That is b.false equal to s.next. What is s1.next is, s1.next equal to begin. So after executing s1, it will go to the begin. It will go to the begin. So that's why s1.next equal to begin. Now we are writing the statements. Semantic rule s1.s.code. This is s.code. Then label of begin. First we have a label of begin. Then b.code. We are evaluating b.code. Condition is true, means it will go to the label of b.true. Then s1.code. Gen of go to of begin. So what is begin? So begin means it is a local variable that holds a new label attached to the first instruction for the while statement. Also the first instruction for b. Begin, actually it is a variable rather than an attribute, because begin is local to the semantic rules for its production. So what is s.next? S.next marks the instruction that control must flow to if b is false. Hence b is false, it is said to be s.next. b.true, the code for b generates a jump to this label. If b is true and attached to the first instruction for s1, go to begin, it causes a jump back to the beginning of the code for the boolean expression. s1.next is set to this label begin, so jumps from within s1.code can go directly to begin. Now we will discuss about the control flow translation for boolean expression. So previously we have discussed about the flow of control statement. Now we will discuss for boolean expression. So Boolean expression B is translated into three address instructions. B is evaluated using conditional and unconditional jumps to the one of the two labels. B dot true if B is true, and B dot false if B is false. So whenever we evaluate the Boolean expression, we have two label. One for B is true. If the B is true means it will go to B dot true. If B is false, it will go to the label B dot false. Now we will discuss about the B1 or B2. Okay, what is our protection is B points to B1 or B2. Okay, whenever we have a OR statement, so when we have a OR statement, so if the first condition is true means the entire expression is true. As per the truth table of OR gate, suppose we have a B1, so we have B1 and we have B2. Okay, so B1, B2, so B1 is 1, means even though the B2 is 0, the entire expression is true. So we are writing a label, so B1 dot true. Whenever the B1 is true, B is also true. Okay, so whenever the B1 is false, then only we will evaluate the B2. So for that, we have to create a new label. So B1 dot false equal to new label. So when B is true means when the B1 is false, B2 is true means then the B is also true. So B2 is true equal B2 dot true equal B dot true. So both are false. Suppose B1 is false and B2 is also false, then the entire expression is false. That is B is false. Now we will write the syntax directed translation for this. So B dot code equal, first we evaluate the B1 dot code, label of B1 dot false, label of B1 dot false, then B2 dot code. Okay. So as I told, if the B1 is true, then B itself is true. So B1 is true is same as B dot true. If B1 is false, then B2 must be evaluated. So make B1 false be the label of the first instruction and the code for B2. The true and false exits of B2 are the same as true and false exits of B respectively. So this is about OR statement. Next we will discuss about the AND. B points to B1 and B2. So when we have an AND statement, if the first statement is false, that is B1 is false means B is also false. Suppose B1 is true, then we need to evaluate B2. Both must be true. If the B1 is true and B2 is also true means then the entire B is true. First one, B1 dot true equal new label. Suppose B1 is true, we need to create a label. B1 dot true equal to new label. Suppose B1 is false, the B is also false. The B1 is false, B is also a false. B2 is true, then B is also true. Okay, B2 is false, then B is also false. Now we evaluate the B dot code. So B dot code equal to, first we evaluate the B1 dot code. So B1 dot code we will evaluate label of B1 dot true, then B2 dot code. Here, if the B1 is true, as I told, then the B2 must be evaluated. So make B1 dot true is assigned as a new label of the first instruction in the code for B2. If the B1 is false, then B itself is false. So B1 false, B1 dot false is same as B dot false. If B2 is true, then B itself is true. So B2 dot true is same as B dot true. If B2 is false, then B itself is false. So B2 dot false is same as B dot false. Next one, not statement. B points to not of B1. So when the B is true means when B1 is false. When the B is false means when B1 is true. Okay. So B1 dot true equal B dot false. as per the not statement, if the B1 is true, then it is equal to B dot false. If B1 is false, then B is true. Okay. B dot code equal to B1 dot code. We evaluate the B1 dot code. So if B1 is false, then B is true. If B1 is true, then B is false. So no code is needed for the expression B of the form not of B1. So interchange the true and false exits of B to get the true and false exits of B1. Thank you.